Hey, we are about to revise circle problems involving Pythagoras. So that's theoretical basis behind the scene, and here are the problems that we need to start doing right now. So let's get started. So the first, 80 is the tangent line, so it means here, and O is the center. Circle has a radius 5, it's here. So keep in mind, and actually here is already marked, that the radius OT is perpendicular to AT tangent line. So it has 90 degrees angle. So we also have AB 7, so we put 7 here. And just find the length of the tangent line. Of course, we need to consider Pythagoras through the triangle ATO. It's definitely a right angle because at the angle of T is 90 degrees. So in order to find or to complete Pythagoras, we just simply write this is unknown, the tangent line, so we need to figure out x squared is simply AO in total, that's hypotenuse, so BO is the last known here. Because it's the radius, so both radius should be the same, it's also 5. So we'll get 5 and 7, 12, 12 squared, and we subtract out the square, the square of the other leg, which is 5 squared. Okay, so we'll get the following. 12 squared is 144 minus 25, and here we'll get square root out of that. All right, so looks like we have some like x equals to square root of, so let's see, let's calculate. Square root of 144 minus 20, 124, so 119. All right, so let's see what's the value after square root. We've got that. It's approximately 10.91 if the answer to 2 decimal place. So actually we're not specifying, but keep in mind that rounding up to 2 dp will give you 10.91. All right, so let's go to the next one. What we have here, a circle has a center O and the radius of 8. So I made the mark here 8, 8. So that because of 2 equal sides, so triangle AOB is an isosceles, so chord AB is 13 centimeters long, so I mark 13 here. Find the shortest distance from the chord to the center of the circle. Alright, it's already marked here as X. O, let's say OC, so that we are supposed to find. This level, as you can see, is pretty simple. CO squared from the triangle AOC, so we consider triangle AOC as a right angle, we'll have CO squared, i.e. our unknown x squared, is equal to square root, not squared, it's 8 squared, so 64, minus AC, but you know, there is a specific theorem about bisector, so if that is a perpendicular to the chord, it splits chord into equal parts. So basically you can use, you know, height in the isosceles triangle is also median, so it split the opposite side into equal parts. So finally we'll get AC to be half of 13. So that's why 13 half, 6.5, which is squared. Okay, so our known x squared will be equal to the following. Let's calculate. So x, i.e. CO, is equal to square root of, let's calculate. So we get 64 minus 6.5, which is squared. I'll get 21.75. And from here we can figure out the square root of it. So it's about 4.66. 4.66 up to 2 dp. Alright, so we got it. Actually, not so hard. So let's go to problem 3. AB is the diameter, okay, and AC is the half length of AB. Okay, so if BC is 12 centimeters long, so put the side which is 12 centimeters long. What is the radius of the circle? Okay, so radius, actually, it's half of diameter. So our basically goes to find diameter length. And we know also that AC is half of AB, so we can mark X as AC, so double X is for AB. So actually, once we found X, it becomes the radius. In our case, it becomes radius because it's half of diameter, which is radius by definition. Right, we also have 90 degrees angle because inscribe angle with 2 with the segment, actually with the chord corresponding to the open angle 180 degrees. It's here, so that's why AB segment as the diameter, so we have 90 degrees. Keep in mind that. So let's complete Pythagoras. Hypotenuse, in this case 2x, so 2x squared equals x squared plus 144, which is 12 squared. Alright, so we squared up each factor, so it's 4x squared, and we subtract x squared, so we'll get 3x squared is 144, from where we can figure out that x is simply square root of 144 over 3. So better just calculate that immediately. And let's see how much is that. So 144 over just 3. Okay, that's what we'll get. And we'll get 6.93. Alright, so problem number 4. So we have ABCD rectangle with side lengths 11 centimeters and 6 centimeters, and it's inscribed in a circle. Find the radius. Alright, what we can do, side lengths 11 and 6, so we can put 11 here, 6 here, and it's inscribed find the radius. So what we're gonna do right now, we can connect A and C, for example, with the diagonal of the rectangle. So what it turns out to be, AC is simply hypotenuse, so radius is inside, and obviously for the rectangle that should go due to the right angle. AC is also diameter, so C is a diameter. Okay, in this case AC is also hypotenuse for triangle ABC, so we can figure out that AC is simply square root of 36 plus 11, 121, if you raise up 11. So AC is, let's calculate that quick. So 36 and plus 121. So we'll get AC is about 12.53. And in order to find radius, we just have that, and we'll get just over 2. This is just over 2. It's 626. Alright, that's the final answer for the radius. Let's get to go start from 5. So a circle has a diameter AB on the length. C is the point in the circle such that AC is 8 centimeters. Alright, so we have a diameter of the length. So normally we need to draw the circle. So don't accuse me in like bad drawing, because actually it's hard and I don't have any tools to draw, so probably I install something else in order to help me with precise drawing. Alright, so we have diameter AB, let it be diameter, and we know that the length is 10, so this is the center. C is the point on the circle, So somewhere, for example, so that AC is 8 centimeters. Okay, we just connect and say that AC is 8 centimeters. Okay, so find the length for BC. I put a red segment, and we need to find that. I put X. So we know that actually to resolve this problem, we know that this is 90 degrees. However, it's not to scale, so don't pay attention to how it's drawn, but actually pay attention to the sense. So we have AB segment as diameter, so ACB is inscribed angle, that's why it's 90 degrees. Alright, so in order to figure out X, you already know what to do. It's just square root of 100, 10 squared, and minus 64, so we'll get finally 6. So actually this segment is 6. And the last one. A square is inscribed in a circle of radius 6. Find the length of size of the square. Alright, so we have the radius of the 6. So put in the middle point, which is the center. And what I'm gonna do, I'm just put the radius. Basically, it's better to put diameter. Alright, this is diameter. And if we mark, so the radius 6, so diameter is 12. If we mark X as the known side for the square, and two sides are the same, of course, we can figure out this triangle is a right angle, so we can complete Pythagoras as 144 equals to x squared plus x squared. We'll get 2x squared. So 1x squared is just simply 72. And now we take the square root of it. So we'll get square root of 72, which is actually about 849. But we need to find 3 significant figures, and that's correct. So I mean the complete answer, like on the calculator, more precise, will be 4852 and something. Alright, so we cut out the rest part, so we have 3 significant figures, and in this case we'll get 8.49 if we round. Okay, so perfect, software has updated and ready to install. So for this reason I just quit this game. Wish you guys good luck. Don't forget to subscribe. Don't forget to press notify bell button in order to have the latest updates. As you can see, we have regular videos, so in GCSE format you will be well prepared, trust me. So just be with me and you will succeed your exams. Daniel Dallas. See you.